Hello world, it's Sumit. So today's session is about deep learning with Keras, where we're going to learn about how to use transfer learning with real-world application using TensorFlow and Keras as a backend. So let's start. Yeah guys, so before starting, I'm going to give a brief outline of what we will going to cover up in today's topic. So what is transfer learning? How it has been different from the traditional machine learning? Why we will going to use this transfer learning and the approaches for using the transfer learning architecture. Well, we're going to see the different end-to-end mechanism from just collecting the data till deploying the results, how it would be. Then we're going to see like VGG model architecture, like the different layers, how it's behave, and then finally at last we're going to jump into the live coding session where we're going to learn about the pre-trained model, feature extractor, and the fine tuning. So let's start. So the first question which hits in the mind is like, what is transfer learning? So as this says, like transfer learning is research problem that focuses on storing knowledge and blah blah blah. So transfer learning is basically is a technique which make anyone life much easier to perform machine learning, where the model is being trained on one particular task and can be used as an starting point to identify the different tasks. For example, this robot has been sitting on the couch and has been detecting on a screen like, oh wow, it's a cat. How it will going to identify? Because we will going to feed him the lots and lots of data on his neural network to identify that it's a cat. So gets more into about it. How machine learning has been different from the transfer learning? Because machine learning and all the previous algorithms that have been designed in a traditional fashion to work in isolation, yes, this model are being trained to solve specific tasks, and every time you need to add a new domain or new things, you need to every time rebuild it from the scratch and train it, which consume lots and lots of time. For example, in this diagram, as you can see, suppose this is my class A, B, C. Let's say cat A, cat, dog, and horses. For example, if I train my model with to identify only cat, so it will going to identify the only cat. So the learning system, what it will going to learn is to identify only cat. In future, if I want to identify him the horse and the dogs, so for that I need to again rebuild him, again feed him those data. So again I need to do it from the scratch. But in case of transfer learning, is been lot of difference. What is it? Transfer learning models has been already been trained on something, like this knowledge has been already been trained on, and that in future, like if he has like cats and dog, it has been already been trained on, and in future you want him to identify the horses or human as a new task which you want to get identify him. So this this particular point, like where it been till where it has been feed and till where it has been trained, that point, particular point will act as a starting point for the next task. So it's not necessary so every time you again go and rebuild it from scratch, again read from scratch, which consumes a lot and a lot of time as compared to machine learning. So this way machine learning is been like overrated, but kind of transfer learning is give you more advantage over the machine learning, and which consumes like in terms of accuracy. If you're going to learn about like in terms of performance, so in terms of performance, like for example the example which I gave you, if suppose for the machine learning tasks, if I'm going to train my model to learn only the cats or learn only the car, so in that case it will going to identify only the car. In future it won't going to identify truck, bicycle, or any other vehicle, because the particular model is been trained only with the cars. But in case of transfer learning, if the model is been only trained with the cars, and in future you want to identify him as a truck or bicycle, then that particular knowledge will going to act as a starting point for you. On pre-trained CNN you will going to identify it. So this will going to here from here, it will going to act as a starting point for the new tasks, where you're going to feed him the more data to identify new types of vehicles. So coming on to the performance, this curves speaks about the machine learning, and this curves speaks about the transfer learning. So which makes it more clear about. So every time you need to perform a machine learning, you need to rebuild your model from scratch, which consume lots and lots of time. So here what it is. But with transfer learning, the benefit is like the model has been already, so this slope you can see here, the gradient, so this particular thing has been kind of, it gives you advantage over the machine learning to learn about the more thing. So it gives you already a beneficial of this much performance, and it gets a highest slope of it to identify the things, and it consumes less time, and well, the accuracy is much more greater than the machine learning. Yeah. Let's say now we're going to talk about the different transfer learning scenarios. So before we begin this, we're going to make it very clear this transfer learning scenarios are been purely based on the size of the data set for the VGG model you will going to feed it. For example, let's say this all three diagram which you are seeing at this end diagram, you are seeing the different kinds of layers. So all this three layer is been from the VGG16 which I have taken. So in this, while covering up with the first scenario, for example, if you don't have any data set, for example, let's say you have two images on your system which you want to get validate whether like what kind of image it is, whether it's a cat, dog, or what is it, and you don't have anything to train on, then you will going to use a pre-trained convolutional neural network model for testing without training on any of the data set. So we're going to cover this up. And the second thing which comes is on based on small data set, so we call it as an feature extractor. What does that mean? For example, you have two different images, like or you have two different folders, let's say cat and dog. In our scenario, what we're going to cover up, we're going to have four different folders like cat, dog, horses, human, and in that, like each folder would be having a number of 100 or 150 images, it's depend on like the capacity of the image what you want to use. But if you have a very fewer data set, let's say like four kind of thing, then we will going to just modify the last layer of this convolutional neural network. Let's say in our case it would be FC4. Instead of this FC 1000, we're going to make it as FC4, because we would be having only four things: cat, dog, horses, human. So for this four different type of classes, we're going to make it as FC4. What is this FC? FC is a fully connected layer. So this was the second scenario, like this we call it as an feature extractor. Moving on to the next, if suppose you have a medium or very large data set to get feed into this neural network, so in that case, you will need to modify few layers of this convolutional neural network. Let In that case, like rest of the layer, you will going to mark as freeze. In this case also, like in case of feature extractor also, before feeding or before training, you will to mark all of the layers as freeze. Then you will to train the convolutional neural network only with the last layer. So the trainable parameter would be only the last layer, and the other weights would be the remain as it is. So in the third one also, like for this medium and the large data set, which we call as the fine tuning of the model, in that you will need to make a few layers based on your requirement or based on your use case. You will need to make the few of it as freeze, and you can modify rest of the layer. By the way, you can modify all of it layers. All these layers are is editable, like you can change all of it. But the thing is, like based on the requirement, you will need to modify a few layers of this convolutional neural network, and you will need to make it as the desired thing, like what you want based on your requirement. So we're going to cover this up in our next in later part of the video. We're going to see this. So this were the three different scenarios. For this transfer learning scenarios, we're going to cover up the three different things. One would be with no data set, one would be with a small data set, and one would be with the medium or the large kind of data set, which we call as the fine tuning. So this is for the transfer learning. So what we will going to do in this particular session, so we will going to see like from end to end since from collecting the data till predicting the result and visualizing it, we're going to cover up everything. First, we're going to collect the data, we're going to pre-process it, we're going to load on the pre-trained network or on the we're going to modify the layer, and we're going to again retrain it. So that means, if suppose if you go with the first scenarios, like you already have an data and you want to test on the pre-trained model, so you can go with this step. Otherwise, if you want, if you have some data, then we're going to customize the last layer of it, or based on our data set, the size of the data set, we're going to modify the few layers of this convolutional neural network. Then we're going to train the model based on our classes, the number of data sets we are having it. As in the last image which I showed you, like there was FC, yeah, so there was FC 1000. So this means like fully connected 1000 classes. So in our example, we're going to cover up with the 4 classes. So we're going to retrain again with the 4 of the classes, and each classes would be having around 200 kinds of images. Like it's a small data set. So we're going to again retrain the model, then we're going to predict the accuracy, and we're going to benchmark the accuracy of that particular model, whether like how much percentile it is predicting the particular test image, what's the accuracy of it. Then we're going to see, then we're going to deploy the result in the using the matplotlib, and we're going to see the accuracy of it. So once that is done, we're going to cover up everything in this particular session. So moving next, so we have the Keras model. So these are the different kind of Keras model, like which Keras is providing. So as you can see here, as of now we are experimenting with VGG16. You know, like there are the similar kind with the VG19 and Resonate 50. So as you can see here, VG16 is of 528 MB and VG19 is of 549 MB. And the difference between them is the number of trainable parameter, which we often call as the weight. So the weights of the VG16 is 13 crore 83 lakh 57,544, whereas of VG19 it's around 14 crore 36 lakh 67,240. So the number of trainable parameter in VG19 is approximately around 1 crore more than that of VG16, and the accuracy is like quite similar. So you can use any of it to predict your test images. Similarly, with the Resonate 50, so the size of the Resonate 50 is definitely, yes, that is around 98 MB, only 98 MB as compared to VG16 and 19. And the number of trainable parameter is being trained on is around 2 crore 56 lakh 36,712. So number of trainable parameter is definitely less as compared to that of VG19 and 16. But if you're going to do a like kind of implementation for the VG16, you will going to have an idea of how you're going to tackle up with the different Keras model. So that will be kind of a generic template which we're going to covering up. They are going to learn about like how we're going to like if based on our data set, how we're going to modify the in between layer, how we're going to train on it, and how we're going to predict it. So let's move forward. Yeah, so first starting off with the VGG16 model, what we're going to see is like the different layers of the convolutional neural network. So here you can see like VGG model is completely is a kind of hierarchical based model, and each layer stores a different sets of data. What does that mean is like you can see here in this diagram, here you can see convolutional block 1. So this is a block 1, block 2, block 3, block 4, block 5 and block 6. So in this particular thing, whenever you're going to feed this convolutional neural network with one kind of image, so it will going to whatever it will been trained on, it each data like each okay, so before getting into this, like I'm going to give you a brief insight on like what is image. Let's understand that. So image is basically like, as you can see, like if you know about this pixel, so pixel is a very smallest part of the image, in the sense like for example, let's say take us this image. So as long as you see this image, it is of highest quality. As long as you can zoom into it, the more you will to zoom into it, you will going to see kind of blurred images, or you will going to see kind of this kind of image. The more you get deep into it, you will going to see kind of pixelate images. So what is a pixel? Pixel is a very smallest addressable control element of an picture represented on the screen. Let's say for example you would have all played Mario, but in that Mario you would have seen the evolution, like how kind of evolution had got the Mario with when the first Mario design was got invented. So that time it was on 8-bit. So you can see here on 8-bit how it looks, and the evolution to this in SD pattern, how it looks now. The more you will going to get zoom into it, the deeper you will going to get this kind of image. The more you will deep in this image, particular image, only this particular section, this ROI of that eye we have taken, we had zoom into it, we had zoom until till we got the last pixelate images. So this is called the 1 pixel. So pixel is kind of only, so pixel we can define for the image which is that is in 2D, and image is always in 2D. So in 2D we call that as an 1 pixel. For example, and what the pixel stores, let's say take this example of an image. This is a Landsat satellite image in which we're going to take up this image, and this image literally stores the data in kind of pixel format. So this image is basically is kind of an array of data. So in this array of data, so each pixel will going to store about some values, and what values, those are the digital numbers. So each pixel will going to have some values, and normally if you're going to read the any image in very sequential manner, like this way, like either ways we can go with, we can read the image. So they're going to learn about each particular image is contains of pixel, number of pixel, the smallest unit which we call as this pixel, and each pixel stores some data. So that those are which we call as the digital number. So moving back, if you understood this image now, so this image, this particular image will, when we're going to train the conventional neural network with this particular image, let's say I am feeding the conventional neural network with only one kind of image. So what it will going to do is, so first this image will be kind of number of a small pixel. So in this pixel, so what will going to happen is, so some layer will going to store the edges of the images, some layer will going to store the only the eye, nose, lips, neck, hair, eyebrows. So those kind of object parts will going to, like you can say the combination of edges will going to store by the sum layers, and the sum layer will be definitely be storing the object models. Let's say the half part of the face, like you can your forehead, your half face, like from left side, right side. So all this kind of thing from one image, whatever they can derive kind of object model, some layer would be storing that. So once we're going to feed the image, so in this diagram you can see this is the image that is of 224 cross 3. What does mean? That means width, height, and the number of channel. So this is a dimension of the image, like for this kind of dimension of the image, so this VGG network needs 224 cross 224 kind of dimension for the image, which we're going to feed as an input image. So for this input image, so we had talked about before feeding something to the image, we have to reprocess it. We're going to make it as in the required pattern, like what kind of in pattern convolutional neural network expect it from image. So we're going to see, we're going to make this image as 224 cross 3, and then in this once we're going to feed it, so this two green layer which we can see here, so these are the conventional 2D block 1. So once this block layer, so again each layer would be of some different dimension, and it goes still from top to bottom unless it get fully flattened up. So you can see once when we were feeding the image, the convolutional neural network with the image, let's say as about 224 24 and 3, that time it was like with dimension, and in the last layer that dimension is about 1 cross 1 cross 1000. What does this mean? That means since the beginning of the image till the end, only the channels will going to increase and the dimension will going to get reduced, let's say till here, until the image will going to get feeded from here, it will going to pass to this layer, will going to come up here, till here it will going to get completely flattened up. So these are the fully connected neural network. So this blue things what you are seeing here, this we call as a max pooling. So in this max pooling, so once max pooling is done for the conventional neural network, it changed the dimension. So it got reduced in the dimension. Let's say about 224 cross 64. It's become 112 cross 112 cross 128. So here you can see once the max pooling is applied, the dimension got increased and the dimension got reduced and the channel got increased. Let's say after every block, once the image got transferred from one block to another block, since the third block, fourth block, dimension is getting reduced and the channel is getting increased. So this kind of this in the entire thing which we're going to do, we're going to tell here this other conventional block which been already been defined, and the last layer which has been already been trained. It's it's up to us, whether we're going to just modify or fine tune the last layer of it to do for the feature extraction, or we're going to freeze some of the layers, let's say we're going to freeze till block 3 or block 4, and then we're going to fine tune only the fifth and the sixth block. Let's say and in this entire neural network we can actually without freezing all of the layer, we can train the model with the entire, and we can change the entire parameter, like what is there inside. It's totally editable. So based on our requirement, in the first one we're going to, from this pre-train, we're going to directly see. In the second one we're going to just modify the last layer of it, and in the third session, in the third part, for the fine tuning, we're going to freeze only few layers of this convolutional neural network, and we're going to see train only with the block 5 and the last layer. So this last layer which you are seeing here, these are the fully connected layers, fully connected classifier in our words we can say. So yeah, so this is for the VG16 architecture. So let's move forward. Okay, so now let's start up with the coding session. So now, before starting up with the coding session, we have some prerequisite. For that, you need to have Python installed with 3.7 and Keras as 2.3.1. So in my system, as of now, if I can show you, yeah. So I have my virtual environment set up as an TF37, which means you can give any name you want. It's purely based on your choice. You can have you can give any environment name. So in this I have installed Keras. As you can see, it is with 2.3.1, and Python, obviously, Python is with my spider. I had installed. So in the spider, Python 3.7 I am using, and most importantly, you can go with any ID you want. In my case, I am going with the spider. It's up to your choice, what ID you want, and you can go with that ID. So now, moving next. So if you have this prerequisite done, you can directly go into the coding, and you can do a live coding along with me, like how I'm explaining. So moving next, the first thing we're going to cover up with the predefined models. So as I can show you, I told you as I mentioned you before, there are three different machine learning transfer learning scenarios. So for this, there are three different scenarios, in the sense, one case we don't have any data set with me. The second case would be I'm having very small data set with me, and the third case would be large and the medium kind of data set. So first we're going to cover up this topic on pre-trained model, how we're going to validate the test, and how we're going to check what the accuracy of that particular pre-trained model is. Then we're going to jump into the feature extraction, and at last, definitely, we're going to do with the fine tuning. So let's start. So the first thing would be predefined model. What does predefined model means? As an example, whenever you're going to start with the Keras, they definitely, as I told you, transfer learning is purely based on the predefined knowledge of a model. That what we're going to test it first. The first thing would be, I would be downloading one model from Keras, and in that Keras, once would be downloading it, I would be validating it with my test image. So what would be my test image? For this scenario, let's say I don't have any data set. I don't want to feed my model with new data set to get trained with. I will just only, for example, I would be only having one image, and for that image I would be validating it with against the model. So what that image would be, for example, in my case, I have taken the test image as like a horse, as you can see. um, this would be my test image. And yes, I definitely have different kind of images in this folder, which I would be validating against. For example, this is a cat, dog, panda, and this is my horse. So I would be testing with this image, because for this image, definitely if you're going to convert it with a grayscale, you cannot find like whether it's a horse or some other animals. Like it's completely in blank. As you can see in the image, it's cartoonish type. So I would be testing against this particular image. So the first thing would be, I'm not sure whether that particular model has been trained with this image or not. This image which I have, this I would be validating against it. So let's start with that. So as you can see, like this is my spider IDE, and in that, like this is my file for this without train model, and I would be validating against one image that would be with my test image. And I've divided the entire file, or you can say the entire script, into the number of different regions, like how we can divide the regions. Now the first thing would be, I would be importing all the libraries that would be needed up by this script. So let's do that. Yeah, so as you can see, now all the libraries had got imported. Once this library had gotten imported, so now we will going to make a model, because like already from the pre-trained model we're going to derive like the model summary out of it. So in my this in this file, I try to put as much as comment which I can put, just because to explain you in future, like if you like, I would be uploading the same in the GitHub as well. So from there, again, if you want to go through each of the parameter, like what is this include top, what are the weights, and what all the different parameter has been used in the different functions, you can go through it to understand it. So the first thing would be, we would be taking the VG16 model, and this VG16, like the parameter, the first it was as an include top as true. What does this mean? This means like all the top layers which we are having it there. As I explained you, I'll show you once. Yeah. So all the top layers, this would be true. So what does this mean? This mean this boolean flag represent to include all the fully connected layers at the top of the network. You don't need this if you are fitting the model on your own problem. So basically, it represents a boolean flag whether to include the three fully connected layers at the top of the network or not. So in my case, I would be marking that as true, and the second parameter are weights. As I told you, the all the layers is been having some weights, or you can call as the trainable parameters. So for that weights, what I would be using, that is the image net. So what is image net? Image net is basically the kind of there I'll show you once if I have the internet. Yeah. So ImageNet was basically an organization database organized like in the world, and in this where they had represented their model, and in that model they came up with the accuracy of more than 90%, and they had trained their particular model with more than trainable parameters. Like they had more number of dat- database images, in that they had got the maximum accuracy out of all the other competitor who had compete against that in that particular challenges. So I'll show you once. Yeah. So now this was the weight, so I'll going to execute this part. So as you can see, my model has got created. Now what I'm going to do is I will going to make the model summary. So what this model summary, as you can see here in my model summary, I had got I had got as an input layer, then block convolutional neural. So this input layer would be like my the image input which I would be feeding into the image. As I explained you in this image, this would be my input layer. Then again would be my two layered convolutional block layer. So this two layer would be my conventional block layer. Then again the max pooling applied. Here I can show you this is a max pooling applied. Then again the third would be two layered convolutional. Again the second block would be of the two layered convolutional neural network. As you can see, these are the block 2 of this stage, and the number of trainable parameters in that is around 73,000. As you can see here in the diagram, this is the output shape of it, like it's 112 112 218 number of height, width, and the channels. So in the first layer it was 224, as I just stated you here. So the number of channel get decreased, so number of channel get increased, and the dimension of that particular image which we are inputting it get decrease, and the channel get increased. So the same thing here in the summary, you can go and check. It's all about the block 3. Again it come with the block 3, then block 4. This was the block 4. Block 4 was of 3 layered convolutional network, which you can see here. Block 1 convolutional network, layered 1, layer 2, and layer 3. Then again the max pooling was applied. So in the same way, the last layer which comes as the, which we call as a fully connected layer, is of the flattened layer, fully connected 1 and 2. So this is the one. So this particular 4 which you can see here, this is my last layer. So once this is done, so I get the summary out of my VGG model. So in my case, when the first time when you would be doing performing a step in your step, it will be get downloaded. In my case, I had already downloaded it. I'll show you once. Yeah. So this is my top layer with including top and with not including top. So this is my VGG16 weight with including top. So by default it get downloaded in the .keras.model folder. I had already explained, I'd already put up the location of it. You just need to change with your username, and you're going to get inside that model. So the first time when you will going to perform this, by default it will going to get downloaded. Once it will going to get downloaded, so every time you can access it from the particular folder from where it got downloaded. So this is the by default location of that particular model download location. So once you got the summary out of it, then you need to first, what I had explained you there, like before feeding any image to the network, we need to reprocess the image in the same dimension as of like what we have to feed there. So in the same way, so before this is my test image. So for example, my test image is in of this name itself, the test image itself. This is my file explorer, and that I can show you test image. So this is my test image. I'll open this up. Yeah, so this is my test image. So the test image is like I would be validating as of now would be the only against the one image. So this is my test image. So this particular thing, as I told you, that I divided in this section. So the first section talked about importing the library. Second section, we're going to talk about pre-processing of the input image, what we would be feeding it to the data, and from there we're going to predict it. Once we're going to predict it, then we're going to see it, the results. So the first thing would be we're going to take the path of the image. Some issues came. Yeah. So we're going to take the path of the image. So I got the path of the image path, as you can see. So I got the image path. So my image path would be test image slash test image.jpg. So I got the path of my image. So once the image path I had got, so I would be loading. So this image which you can see, I had imported the library from this API like tensorflow.keras.preprocessing. So this, in this I forgot to mention this TensorFlow, don't get confused with it. When you explicitly don't need to go and install the TensorFlow. Once you're going to install the Keras, so by default with that dependency, TensorFlow will going to get installed in your system. As you can see, by default, when you install the Keras, it has a dependency over the TensorFlow, and it will going to get installed with the version 2.1.0. So it will going to act as a backend for you. So once that come get downloaded in your particular virtual environment, so from that you will going to import this library image. You will going to load the image with the target image path which you had assigned with, and make the target size as 224 224 224. So what this mean, the target size would be of dimension 224 cross 224, with height and width of the dimension of this particular target size image would be this. So this would be like whatever the size of it, we're going to make that dimension of it across 224 cross 224. So this I would be doing it now. I did it, yeah. So in this img you can see, yeah, see the size had got 224 cross 224. This is the size of, or you can see the dimension of that particular image which I had processed it. So once image got processed, so image is nothing but an array of data which we can say. So once that comes, we're going to convert it to the numpy array. So how it would be, image data will I want to take. So the image data will come, as you can see here, it's the array of float 32 which got converted with 3 channels. So what does this 3 means? This is a 3 channel image. So the height and width and the channels of it. So image data, yeah, I'll show you, yeah. So this is height and width and the channels of it. So once this image data get into it, now the first thing would be, I would be printing this data to show you what exactly it is. Yeah, the same thing which I had shown you in the variable explorer, the same thing is I had printed it. So once that comes, I need to reshape my data, to reshape my image data. So to reshape my image data, first I'm going to expand the dimension of it. So now you can see, once I executed this, previously it was 224 cross 3. Now it became as image data 1 224 3. So once that comes, it got we had expanded the dimension of that particular image data. Then it we can reprocess the entire, this is a pre-process input that again we have taken it from the TensorFlow Keras application.VGG16 for the pre-processing thing. We had taken it. It's a inbuilt API for that. We're going to pass the image data into it. So it pass the image data into it to reprocess it. So once the pre-processing of that image data is done, we're going to print the particular thing. So yeah, you can see this is the shape of that particular input data. So once that is done, so your image is kind of ready, your pre-processing of the image is done to feed it to the neural network. So we're going to take one variable like prediction with the top layer. In my case, I had given as true. Yeah, so this include as true, which I had given it. So what I'm going to do here is, oh, it got clicked. Yeah. So what I will going to do here is the prediction with the top layer. I will going to take it. So now my model was ready. So in that I would be doing F9. So this model with top layer. So this again got array of 1, 1000. So what does this mean? So model with 1000 classes. So what does this mean? This means like the image which I had shown you, I'll show you once. Yeah. As you can see here, the last layer of this fully connected classifier is of FC1000. So this 1000 means the last fully connected classes, like it is of 1000 classes. So in this case also it is of 1000 classes, and it would be predicting the particular image data against this 1000 classes. So for this 1000 classes, like I got the prediction with the top layer for this. Once this prediction I got, I would be decoding the prediction, which means decoding the prediction means like I got an image, like I got some value against like prediction. Now with that prediction, like let's say I got 0 1 something, I got the numerical value. With that numerical value, I would be passing it to the some classifier to decode it against like what kind of label it had got tagged with. Like let's say whether it's a cat, dog or something, which particular label it got tagged with, and that particular prediction, this inbuilt API for this TensorFlow, it will to give me the predicted label. So you can see I got a list of something. So I got a list where it says about gray fox, red fox, and it's the size of 5. So definitely, yeah. So you can see I got a tuple of gray fox, red fox, scorpion, kit fox, and chihuahua, something like this. So I got a list of all those 5 prediction from the model and with their accuracy. So the highest accuracy with the gray fox 0.119 and other with 101.06. So I'll going to decode this prediction. So once this I got the image label from it, so I'll going to retrieve the first value out of it. So this predicted label gave me as gray fox with all the values. So when it gave up with the accuracy as well, it got a gray fox and with 0.111. So once I got this, I'm going to print it. So in the printed format, I got the predicted image. It says me as a gray fox with 11.20%. That's weird. Yeah. So this was the first thing which we had trained with the. I want to replace this test image with my cat image, which I'm already having in my test folder. So inside that, I'm going to load my model. Oh. I'm going to load my model. So once this model is loaded, yeah. So once this model is loaded, so in this you can see when this model had loaded, I loaded this model. This image pattern came up. So I'm going to do the image part. So I got the image part as testimage.cat.jpg. I got this. Now I want to load the image. When this image got loaded, I want to convert it to the numpy array, which I got converted. Now I'll want to expand the dimension. So you can see this dimension got expanded. Now I'm going to pre-process the input to feed it to the convolutional neural network as required by the VGG16. So image data had got changed. So image data had got processed itself. So I'm going to print the shape of it. So this is a shape. So once it's got done, I'm going to predict the feature out of the model. So you can see when I did that, I got the model summary up to FC1, FC2 and prediction. So this is my last layer. This is my last layer which I had already shown you in this diagram. So this would be my last layer. So like where we are seeing this as FC1000. So I just renamed it as a prediction. So this is my last layer FC1000. So the number of trainable parameter which I had at around this much. So now for this prediction which I had given it, so I already got the feature out of the model. So this is my feature which I had already got out of the model. So now I'm going to convert this feature to the human readable format, which is the input API for this decode prediction, which I had already explained you. So this would be decode. Oh, something went wrong. Yeah. So I just decoded the prediction. So label I had got the list of something. So I got the hamster, black forest, something I had got. So I'll check it out, take out the max probability out of it. F9 predicted label I had got. So now I'm going to check it against. Okay, so it says me as hamster, the prediction label, the top layer with the feature which I had got. It was had predicted so many things. Out of this I have to take the highest one, but it had predicted me as an hamster with 35% accuracy. So let's see. Yeah, so in the same way you can make the VGG model as include top as false. You can make the summary out of it. So I'll show you this part as well. Make that as false, you make the summary out of it. So you can see here it had came till block layer 5, conventional block layer 5. So it had excluded this last fully connected classifier, and it will going to you like as as I told you, like this include top is true or false. It's a boolean flag which determine like whether the last layer we need to include at top of this convolutional neural network or not. So once like when I had given the input as true, that time it had included all of it. When I'm making that as false, it had excluded this part, and it's going to take up only till this layer. So till this layer, like I got the number of trainable parameters, non-trainable parameters, and all the parameters which I had got here. So in the summary, I can check like it had displayed till convolutional neural network block 5. So in this also I can test with the cat image. I can extract the feature out of it. I will load the image. I will want to do this, expand that dimension. Then I will want to reprocess the data. Once the data got reprocessed, I'm going to take the shape out of it. Then finally I'm going to predict the feature out of it. So you can see here this prediction without top layer, it had given me the feature 1 7 512, which means till that layer it had given me extracted, and it had given me the feature for the predicted image. So this were just the basics, so which we had taken out with the pre-trained model for the convolutional neural network. So once this is done, so now we are going to move up to the next part where we will going to learn how we can, I'll show you. Yeah, so the next part would be the feature extractor. Like for example, in the sense like I have only got a small data set in the sense, for example, I got the data with, let's say, cat, dog, horses, women, and each folder I had got around in my case I had got around 202 images. So for this 202 images, like for this all these 4 folders, it would be around 808 images. 202 into 4, yeah, so it would be 880 images. So for this kind of a small data set, we're going to go up with the feature extractor, where I would be freezing out of this entire convolutional neural network. I would be freezing all the layers, and I will going to only modify the last layer, and modify in the sense like I will going to make this, instead of FC1000 I will going to make that as FC4, because it depends on the number of the classes which we would be feeding to the neural network. So in this, the first step would be like the same thing. We will to reprocess all the data, where would we do the pre-processing of the data to feed it to the model. Then we're going to reprocess the image list, like what kind of image list we are preparing it. We're going to pre-process it. Then we'll define the classes and the label. So based on your trainable category image count, like for example, like cat, I will be identifying that as 1 or 0, like let's say 0, then dog as 1. Then in that sense I'm going to categorize or label each of the folder with some specific number or something. Then we're going to convert the label into the hot encoding. Hot encoding, what does it mean? I'm going to explain you in the later part of the video while explaining the code. Then we're going to shuffle the data, split the data, data in a sense. It's always a good habit. So whatever the data you have, some part of the data you keep it for the training purpose, and the other part of it, it's based on the percentage. You can divide it, like how much percent you want to keep it for the training purpose and how much you want to keep it for the testing purpose. Like on some part you will going to train it, on other part you will going to test it. So once that pre-processing of data is done, we're going to move on how we are going to tweak the model, so we can create a custom layer with our required number of classes like what we have. Then we're going to create a model from the image input layer, and then we're going to freeze all the layer, and we're going to train and compile the model. So once that part is done, we're going to save the model to some location let's say after every POC or after every point, like we want to save the model and we want to check like how much the accuracy it got corrected. Based on the accuracy, like how much it got done, whether it got overfitted or underfitted, like on that loss percentage we're going to see, and we're going to save the model, then we're going to benchmark the accuracy, then we're going to test on particular kind of image. Like if I'm going to feed the model with my test image, what accuracy and with what thing it will going to give me up. So we're going to cover this up. So now we're going to move on to our code. Let's say this. Yeah. Now for this class, we're going to learn about how we can customize the last layer of this VG16, and we can again retrain with our required data set. So now, before moving, I'll show you, like for this example, as I already told you, we're going to modify only the last layer. Instead of FC1000, we're going to make it as FC4 based on our data set. In our case, we have only 4 classes like cat, dog, horses, human. We're going to modify based on that. So now what we're going to do is we're going to import all the libraries. Once this library got imported, so this depends like whether you want to do or not, like this would be reprocessing of data as I explained in this classes as well, like what and how we are uh, did tell you like how the input image we need to reprocess it before feeding it to the convolutional neural network. And first we're going to take the image path, then we're going to convert to the numpy array, then we're going to expand the dimension of that particular thing, then we're going to preprocess the input data, then we're going to print the data. So let's do that. So here the output of it. So here it came, the input data shape is in of this format. So once this come, so once the pre-processing of that particular so the input image is done, like what image we need to test image, what we're going to test it, for that we're going to reprocess it. So once that is done, so this is optional in our step, like whether we want to do it or not. This is required only for the testing purpose. So now after importing the library, the first thing what we're going to do is whatever the neural network we need to, with the neural network, with whatever the data we need to feed the neural network, for that we need to reprocess the entire data, which means let's say for example this cat folder. As of now in my cat folder it has around 202 images if I'm not wrong. Yeah, so it has around 202 images. There could be a possibility the dimension of the each of the images would be like this would be in some of high format, this would be of less format, in the sense that the dimension, height and width of this particular image would be something else, and for this particular image or the random images it could be of some different shape and dimension. So first thing we're going to reprocess the data and make the entire images, like what we are about to feed to the neural network, entire trainable data is of the same format which is required by the model. Once we're going to do with that, so let's do that part. So here I'll going to go to my current directory. So this is my current directory, right? So this is my current directory. Yeah. So I'll get my current directory. Once I get my current directory, I will go inside the data folder, which is inside the data which I have kept all the trainable data. So once I'm going to get there, I will going to take the list out of it, like how many do I have, like the directory data list. So directory data list speaks about, it says a list of 4. So what is it actually? Cats, dog, horses, human. So these are the 4 folders which I am having right now. So it had gone taken all the folders inside in it. So we're going to make one list of the total images, like whatever the we're going to adding it up after processing of the data. So this entire code snippets talk about like after getting into each of the data, and for the each of the image, one by one we're going to go to each of the folder, and one by one we're going to go to the entire image. And let's say like first we're going to go to the entire list. So the image list would be of all the dataset folder which I am having about cat, dog, horses, human. So inside the cat, I'm going to hover over each of the image. Let's say cat 1, cat 2, cat 3, cat 4 will go into the each one by one. Again, the same processing of the data we're going to do it. We're going to load the image. We're going to convert it to the NumPy array. Then we're going to expand the dimensional. We're going to reprocess the input. Once that is done, at last we're going to append everything in the one list like what we had already created. So let's do that. Yeah, let's say you can see like all the data which we had kept, we had reprocessed the entire data and the shape which we had printed. So all the data and all the files, like all the image files which we are about to feed, is of the same dimension. So when this part is done, whatever the list we had taken, so the entire list, we have to reprocess the entire list. So this image data now, as of now, like I'll show you in my this image data is, let's say, uh, okay, so this is of size, yeah, 1 comma 224 comma 224 comma 3. So this is of height and width of 224 cross 224 and 3 cross channel. So once that is done, we're going to roll the axis. So once we're going to roll the axis, image data has now become the same as it is which was before. So once that is done, we're going to take the first of the image data. So the image data, now we have taken it, so now we're going to print the shape of it. So the shape, it had become as 808 224 comma 24 comma 3. So what this means, this means we have total images, the number of images which we are about to feed, so it had become as 808. So the total images which we are having, like let's say 202 202 202 202, so total of 808 images what we were having. So based on that, it had got 808 images, and with the dimension of 224, height and width, let's take rows and column and the number of channel of the images. So the size of the each images would be of this dimension and the number of images. So once this is done, now so now the part comes, like once we had reprocessed the data, now we need to label them to make it understand. Let's say I defined the cat as 0, this as 1, this as 2, and this as 3 before feeding it to the neural network. So I'm going to define the number of classes here. So I'm going to define the number of classes. So once these classes had got defined, so I'm going to print the image data of that. So the image data, it contains total of 808 images. It's the total number of trainable sample images. So once the number of sample images comes, I got the number of samples which was around 808. Yeah, number of samples, it has grown 808, which is the, so once that is done, so I need to create the label for each of the image. So I need to label, let's say I have to go and make each of the image. For all the cats, I would be marking it with one significant label. For the other dogs, for the dog images, I would be marking as the other significant labels. In the same way, I need to mark a width for all the different kind of folders, like all the different classes which I am having, to differentiate between, like this I can recall as 0, this I can 1, this I can recall this as horse as 2, this we can recall as 3. So for that, like I'm going to create the numpy ones of label. Let's say I'll do this. So the labels which I had created, so I'll show you, I had created the numpys of ones which is on this format, as you can see in my console. So once this is created, now each of the label, let's say from 0 to 202, I'm going to assign as 0, which was definitely of cat. From 202 to 404, that was of dog, I'm going to assign as 1. So in the same way, I'm going to do for the rest of the two folder. I'm going to assign the label. So let's do this. Yeah. So I just assigned the labels, one that is assigned. So after assigning the label, I'm going to print it to show you. Yeah, see. So in this list, you can see, so half of the thing which we have applied as 0, 1. So again 1 for the again 202 images. for the 202 labels, then again 2 for the other 202, then again 3 for the other 202 labels. So once that is done, so we're going to transfer each of the label, whatever the labels we had created, now we need to map with our images. So once the label had got created, we need to map each of this, like this particular thing I need to map with cat, this particular thing I need to map with any of the dog, horses, humans. So for that, what I'm going to do is, like, I will going to use this already API is there from the MP utils, which come from the Keras, I guess. Yeah, which come from the Keras utils API. From this module, I'm going to use this API MP utils. So it will going to convert it to the categorical labels. So what does this do? It do it on hot encoding, which means it will going to convert it to the binary class matrix for each of the matching against for each of the labels. So the class label will going to get tagged with each of the labels what we had marked there. So let's do this. So this got converted binary class matrix. Let's go and check this out. Yeah, so this has got converted. So you can see here, so once this is done till 202, it would be 1 here, then again from 202 to again 404, it would be for this column 1, it would be 1. So in the same way, yeah, see, this is coming as a blue color. So now moving on to the next one, it will be as 1, yeah, for the second one, and for the fourth column it would be from 604 to 8, from 80600 something to 808. So once we had generated this binary class matrix, so once that is done, now we're going to shuffle the data. So in shuffling the data, we need to have the image data what we had already created. We need to have the binary class matrix against which what we are trying to shuffle, and we need to keep the random state. So in my case, I have given the random state as 2, which I had shown you. So I have this random state. So once this shuffling of data is done, so it's always recommended to have to shuffle your data. So once the shuffling of data is done, so I'm going to divide my entire data into number of runnable pattern and the number of test pattern. In my case, I have given the test size as 0.2, which means like the 80% of the data I would be using out of all my data, which has 808 images. So in that 80% of the images I would be used to train the neural network, and the rest 20% I would be using as to kind of testing the neural network. So I had given the random status 2, and I'm going to with the inbuilt API which comes from scikit-learn. So from that you can split up the data and you can check. So now we are done with the pre-processing of data. So this entire region, like for pre-processing of data, what we are about to feed to the neural network, our part is done. So now the next part what we're going to see is like how we're going to make the model. We're going to tweak the last layer of it and make it understand with our like 4-class classifier, and then we're going to train it, which would be actually the heart of the programming. So in that case, first we would be loading the input data. Once we're going to load the input data, then we're going to create the VGG model out of it. So once my model is generated, so once my model is done, so I've given the include top as true, which means I would be including this top layer like connected classifier on this neural network. If I would be given as false, it would be treating till this layer. Now giving that as true, it will be taking this as in for the neural network, which would be about to modify. And obviously the weights which we had kept as image nets, and the input tensor which we had given is of that is of the image input, which means like this is the desired output which have been required, like kind of the target size like 224 comma 3, which means height, width, and the number of channels of this input image it would be.
So once that is created, I'm going to print the summary of this. So you can see here the last layer which I had is the prediction layer, and and it displays the total parameter, trainable parameter, and the number of non-trainable parameter. So once I get the summary of it, so I will going to take up this last layer out of this FC12, FC2. So taking up this as an output, so I took the last layer. So once this last layer I got it, I'm going to print it to verify whether that is not or not. Yeah, see, so this is the last layer which I had got from this convolutional neural network. This is FC12, which I had shown you as this part, FC4096. So once I got that FC4096, see the number of classes is been 4096, and as of now the last layer which has gotten this model is of 1000 classes, which we are about to modify now. Once we got the last layer, which would act as an input for the next custom layer which we are about to design now. So as I told you before, the number of classifier which I have right now is of 4, like cat, dog, horses, human. So based on this, I would be defining my number of classes. So once my number of classes is done, I would be which requires that this is a dense API, like for which you are about to get your own custom layer, and where the input is the output of the second last layer, which means the number of classes I would be required as an parameter. Activation I had kept as a softmax, which has been used for this VGG16. The activation function. So what is activation function? So basically, to understand in very simple, um, it is like it tells a neuron to whether it should trigger or not. So in my case, activation function I had kept as a softmax, which has been used by the VGG16. There are so many different types of activation functions, like step functions, sigmoid, ReLU, but in this case we would be using as a softmax. And the last parameter which I had kept is as a custom layer. So as of now, you can see the model is of the name is of predictions, which we are about to modify. So once we're going to create this custom layer, this name will going to change with custom layer, and this the number of classes, instead of 1000 it should become as 4. That's what we are about to modify. So let's do this. So my custom layer had got created. So I've created my custom layer now, which I will going to feed in my model. Yeah, so after feeding in my model, so my custom VGG model had now got created. Now I'm going to verify it through my summary. So you can see here right now, this the before it was having as prediction, now this had got changed. Now it had become as custom layer 4, and with a number of classes like 4 classes, and it has a number of trainable parameter like what we are about to feed in. Once that is done, so once my custom layer is created, so once I change it from FC1000 to FC4, now what the next part what I'm going to do is like the next step. So I will going to freeze all the rest of the layer which I don't want to get a strain. I don't want to train this again and again, so I'm going to freeze rest of the layer, and I will going to train only on this particular classifier which we had modified just now. So for that, like I will going to loop through each of the layer, and with I'm going to mark that as false. So after making as false, I'm going to cross verify and check whether that is still trainable or not. So yeah, that is not trainable. It displays the output as false. Now that is not trainable at all. So once that is done, now I'm going to compile my VGG custom model which had got created. So the loss which I had kept as a categorical cross entropy optimizer which I am using that is an RMS prop, and the matrices is an accuracy. So I'm not going very deep into this. I will hope you will know about this. So once I will going to compile this my VGG model, custom VGG model which we had created. So my VGG model had got compiled. So once my custom VGG model had got compiled, the next part would be like to train it. So to train it, So I would be running this part of the code, but in my scenario as of now, like it takes around more than 1 or 2 hour, or the number of entire night. It depends on the size which and the verb and the epochs, like on based like what I had given the parameter, like how long it will going to get trained. In my case, it takes still hell lot of time. So in that case, like I'm going to explain you this parameter, like how it is. So for this custom VGG model which I had created, there's a fit API to train this model, and the required parameter which it would be requiring is the xtrain. So if you can remember few step back in the previous step, we had split up the data like in 80% and the 20%. So the 80% which we would be training it, and the rest 20% on which we would be testing the data. So I can show you this once. So this is the way which I had trained the model. You can see here. So this is the train sample which you are seeing, that is the 646, and the rest 20% is 128 on this sample. So that means like we're going to validate on the rest of the 126 sample, and we're going to train it on the 646 sample. So it's up to your choices, like on your requirement, like how you want to split up the data. If you want to train on the entire data, it's up to you. You don't need to perform this step, it's not that mandatory, and you can test it on the unseen data what you want to test with. So now, so this was the first parameter, and the second parameter was like white train. So this parameter means like on what thing will going to give the output as. So this basically gives the output, and this is the batch size. So basically the batch size. So what is the batch size is? Batch size is the kind of segmentation of the whole data into the smaller part, so that like it can process the whole data individually. Which means like if I'm giving the batch size of 32, so at a time it will going to take around 32 images at a time to feed it to the neural network to train with. So it will going to do in a batch size of 32, 32, 32. So normally what happens, the bigger the batch size is, the better it is. The smaller the batch size is, it's very lenient. So it's better to have a good decent amount of batch size. And the next parameter is epochs. Epochs is like the number of times it had to run through the train, the number of times it had to loop over to train it, in order to, in order in the sense like in order to understand, like in order to train the entire model. So the number, if you are giving too much of the epochs, like in that case it would be of kind of you are overfitting your model. If that is too less, it would be underfitting. So it's always recommended to have then epochs of kind of medium range size. It would be better for everyone, like for the better accuracy of the model. And the next thing is verbose. Verbose is nothing but is kind of an progress bar which you are seeing, which you can see at time of whenever we are training the data. Let's say in my example, if you can see this part, like whichever is happening while you would be training it, so it would be moving like from this end to this end, it would be moving one by one. If you are giving the verbose, if I'm giving as 1, it would be moving. If you are giving as 0, it would be silent, it won't be doing anything. And if you are giving the verbose as 2, in that case it would be giving as the kind of one line what you are seeing here. So in my case I'd given as 1, so it would be moving one by one in a sequential manner, like how kind of progress bar, how we can see the data, like how much it had got trained for that particular epoch. And this is obviously the validation data on which we will going to test it. So once my VGG model had got fit, and we're going to test on this particular model, we're going to see the accuracy. So once my model had got trained, we're going to train the model and we're going to test on rest of the images. Then we're going to see like what's the accuracy of it. Then we're going to particularly benchmark the entire model. In between, if suppose, let's say for example, if you are training the data, you have an epoch of 12, in between you came along till 4th, and in between it somehow your system got shut down or got restarted. So in that case you can create one you can create this mid check like model checkpoint. So what this will going to do, so after every epoch, like after every epoch, it will going to save the model for that particular point. Like if suppose I did till 4th, it will, and on 5th it had got corrupted, or in between when it was been trained on the 5th epoch, it got corrupted. Then it will going to treat the 4th as the last checkpoint, and based on this it will going to create a callback to save that particular model. So in my case, like I had already compiled it, and already created the model path, like where it has about to get saved. So this is my model path, models dot custom layer 4, which I can show you. Yeah, so as you can see here, this is a model which I had trained and created. Like it took around more time to get done, so it was of 528 MB. So once my model had got saved, so in this way, like I can get a callback and save like after every epoch if I want to. So I can create the time, like and how much time it had got done. So after every epoch, it will going to give you the validation loss and the loss percentage. So once while you are training the data, you can stop in between if you are seeing the loss is getting less than zero point 0.5, which means like for having a good kind of accuracy. So at last when we are treating it, so when we are done with this training data, when we are already trained the data, when this already had got done, then we're going to print the final loss of it and the accuracy of it. In my case, the loss is 0.1233 and the accuracy is 98% on against this validation test data which we had already split it up. So my model accuracy is done. So now the part which we're going to do is like once my model got created, we had tested against this validation data. So now we can go along and we can test with we can visualize the data, and we can see like how we can show you. Like let's say I'm going to show you, I'm going to run this part using the matplotlib, and I'm going to show this part. In my system it takes some time, it gets hangs in between. Let's say how much time it takes. It takes a bit amount of time to show it up on my screen. I'm not sure why it's getting hanged most of the time while running this matplotlib. So let's wait for this to come up. So once this part is done, so we're going to like show up in the kind of loss through graph, like how much loss I have, how much validation loss I have, how much accuracy I have. So I can visualize all my data with loss and accuracy using the matplotlib. So here I can show up all my data. So by this, like we had covered up this entire thing, like saving our data, testing against this validation, splitting of the data, and benchmarking with that. So we had covered up this entire thing and the accuracy of this. So this we are done with the feature extractor. So once we are done with this, so moving on to the next, the last scenario which we are about to cover up is the fine tuning. The fine tuning of data. So it is like the medium. In case if you are having with the medium on the last side data, in that case you will going to go up with the fine tuning of data. We're going to freeze few of the layers, and after that for few of the layers you will going to train it. So in this also we're going to follow the exactly the same steps like we had already done. Like for the pre-processing of data, it would be the same. Then creating and training of the model there, while creating the new layer and freezing few of the layers based on till here we're going to get the last layer, and till from here we're going to freeze the entire trainable data, and from here we're going to get the last layer and we're going to tweak the rest of the layers. So we're going to cover this sub part in the fine tuning. Let's see. So in this you can see the entire coding pattern and the structure is same like as of what is it is, and I would be uploading the same in the GitHub. From there you can take this up. The only thing which you're going to change here is about while training. So you will going to get the VGG16 model here. Once you got the VG16 model, you created a summary. The last layer which you would be taking as a block 5 pool, which means you would be taking till block 5 pools. 1, 2, 3, 4, 5. You would be taking this as the last layer. You would be taking as the output, and in that last layer, so well, I'm going to print this and show you. So before that, I would be needing to import all my libraries. So I've imported my libraries. So one my libraries got imported. V16 model educated. So I'm going to print the summary out of it. Here. So when my summary is created, you can see here this is like V16. It would be the same. Now I'm going to take my the last layer block 5 pool. So I'm going to print and check, recheck. Yeah, see. So this is my block 5 pool with the last layer. For this last layer, now what I'm going to do is I need to flatten this up. So the output of the last layer would be act as an input for this flatten layer. So now I'm going to flatten this up. Once the flattening is done, now here you can see I am for this V16 I am using the activation function as ReLU, and the name which I had given as FC1. So it would be the name, same name. It won't be the much change. You can modify the name. The second layer, dense layer which I am creating is FC2. Once that is done, so using this softmax dense one, I would be adding my last layer which would be the output of this one. So my model, so now I'm going to create my model. So once my model is created, you can see, yeah, so you can see my output layer which I had created. So this is the name which I had given as output layer. So this is the name of this output layer with the 4 class parameter which we had created, and the number of terminal parameter is 516. This is very less as compared to the previous one. In previous one it was like around 16,000, and now it, in my previous model it was 16,000. In this model it is 516. So before that, like those layer like I had given as FC2 and FC1. So this is my FC2 layer and FC1 layer. So my model had got created. So once my model had got created with the number of trainable parameter, like I am feeding to this 3 layer of this neural network. So for this, like for feeding to this 3 layer of the neural network, I would be freezing all my rest of the layer. I can check, and the only difference which would be having while compiling the code while creating this customer VGG model is like optimizer. Like in this case, I am going with ADA delta. So this is the only change which we are doing with the model compilation. Rest all thing are same, which you can go along with the code. This all thing, the how we are creating the callback, how we are creating the callback, we are calling it, saving in between the epochs, like how many time it had got run, and validating against the data. So this is like kind of end to this. So yeah, so till here my model had got done. I can show you this up. So you can see here like my this part is done. So yeah, so you can, this way you can plot and you can check this losses and accuracy. So this part is done. Till fine tuning it is done. Like we are done with fine tuning of the data for the median and the last set. So the last part we are moving it, so that would be the testing the model. So for testing the model, normally if you had the same model with you for the image classification problem, either you can go with the image prediction, video prediction, from where you're going to extract the number of frames. Based on the frames, you're going to identify it, and the last part would be webcam detection. So in this webcam detection, normally what happens, you like from the like as in camera input, you can predict by the number of frames like which is the object detection we are using it. So this is just a sample image for this camera prediction which I did on my image. So it works fine. It shows as car is 52% and person is 82%, which had modified it. So this would be the kind of exercise for you to testing the model, or I would be covering up in my next video how to test a model with a given input, with the given input as a model with the saved model, how you can predict the images. So this we are done with this particular VGG16 model. So what next? So next would be like learning about VGG19 and ResNet 50, which were the top two models of this Keras. So there also we will be having the same pre-trained model feature extraction and the fine tuning, which would be going along with VG19 and ResNet 50. So the code snippets are available on Kupler and GitHub, and I would be sharing the link with you. So this is my Kupler website, and this is my GitHub ID. I'll show you once. So this is my GitHub ID. So in my GitHub ID, I created a repository for this deep learning where I would be committing all my code. So from there you can go and check all the files like what you need. Along with this, I would be zipping up the data set which I'm having, from which I trained the model. I would be uploading it here. From there you can go and check. So this is my username. You can go and check this part, or you can go with Kupler. This is the website where I used to write the blog. You can check up with the Kupler site as well, like where we used to write the blog, or either you can learn up with the different kind of Python things which you kind of experimenting at. You can go and check it out. So all this would be available in this site. So yeah, that's it. So this is my first video, so I need a genuine feedback on this. So better like, subscribe and hit the bell notification icon in the channel, and stay tuned for the next video to come up.